Alright, so this is the answer key to the review. It says a snack bar cooks and sells hamburgers and hot dogs during football games. To stay in business, it must sell at least 10 hamburgers but cannot cook more than 40. It must also sell at least 30 hot dogs but cannot cook more than 70. The snack bar cannot cook more than 90 items total. The profit on hamburgers is 33 cents and the profit on a hot dog is 21 cents. How many of each item should sell to make the maximum profit? So X is the number of hamburgers sold, and Y will be the number of hot dogs sold. So one keyword that kind of gives us away is maximum profit. So we know this is a linear programming problem. Let's go ahead and see. It says it must sell at least 10 hamburgers. So hamburgers is X. That's going to be that X is greater than or equal to 10. And the next one says, but cannot cook more than 40. So that's going to be X is less than or equal to 40. Alright, for the next one, it says it must also sell at least 30 hot dogs. So Y is greater than or equal to 30. And for the next one, it says, but cannot cook more than 70. So Y is less than or equal to 70. And then last thing we see, it says the snack bar cannot cook more than 90 items total. So that would be X plus Y is less than or equal to 90. And from here I would just subtract X and I would get Y is less than or equal to negative X plus 90. And so now we have these 5 equations. And last but not least, we have the profit of a hamburger is 33 cents. So that would be P equals 0.33x plus, and they make profit on a hot dog of 21 cents. So 0.21y. And this right here is our objective function. This is where the vertices where we figure out will plug into to give me the maximum and minimum profit here. Alright, so let's start by graphing this line right here. So let's change the scale. I'll go by tens. So it'll be 0, 10, 20, 30, 40, 50, 60, 70, 10, 20, 30, 40, 50, 60, 70, 80, 90. Alright, so the first one, X is greater than or equal to 10. And I know I shade to the right because it's greater than. For my next one, X is less than or equal to 40. So 30, 50, this is 40. And then this one here, Y is less than or equal to 30. Or sorry, greater than or equal to 30. So I shade above, so right now it's in this region right here. Y is less than or equal to 70. So we have this rectangle that appears right here. And then my last one says, starting at 90, down 1, right 1. So it appears my shaded region is right in here. So the vertices I have are 10 and 30. I have 10 and 70. I have 20, 70. I have 40, 30. And I have 40, 50. So now I'm going to plug each one into here. So this would be 0.33 times 10 plus 0.21 times 30. And then I'll do that all the way down. Alright, and from here, you would work out each one individually. So let me just work these out real quick. So let's see, 10 comma 30 is going to yield $9.60. 10 comma 70 yields $18. 20 comma 70 is $21.30. And 40 comma 30 is $19.50. And last 40/50 is $23.70. So this one right here is going to yield the maximum profit. So I would have to sell 40 hamburgers and 50 hot dogs to maximize my profit at $23.70. Alright, on to the next one for number 2. It says determine whether each ordered pair is a solution of the system of inequalities shown. Alright, so the first point I'm just going to plot it 3, 1, so 0, 1, 2, 3, 1. That point does fall in the shaded region, so that's going to be yes. So this is a solution. For the next one, 1, comma 2. So it's in the intersection of these 3 lines, but since this line is dashed, this is not a part of the solution set. For 2, comma 3, 1, 2, 1, 2, 3. It's right next to the solid region and it's on the solid line, or the triple shaded region and solid line, so this one's going to be a yes. And then the last one, 3, 0, 1, 2, 3. It's on right next to this triple shaded region, but it's on a dashed line, so this is not a solution. Alright, next thing, we'll come up with the equations. We'll start with this solid line right here. So we can see that the y-intercept, so let's put slope and y-intercept. So the y-intercept we can see is at 1. And here, if you go up 1, right 1, that means it's positive 1. So equation 1 would be y is, the shading is below, and it's a solid line, so that's going to be less than or equal to 1x, positive 1. So we're putting that slope y equals mx plus b form. Alright, we'll call this one right here equation 2. And once again, we have m and b for slope and y-intercept. Our y-intercept we see is 1, 2, 3. And here we can go down 1, left 1, right 1, so that's going to be negative 1. So y is, the shading of this dashed line, it's above it, and it's dashed, so that's greater than negative x plus 1. And then for our last one, we'll call this one here equation 3. So it's a solid line, and the shading is above it, so that's y is greater than or equal to. For my y-intercept, I can see it's at 1, 2, 3, 4. and my slope goes down 1, 2, and right 1, so that's negative 2 over 1, which is just negative 2 when you simplify it. So this would be negative 2x plus 4. So those are the three equations that make up this system of inequalities, and A and C are the ones that actually work. B and D are not solutions. All right, on to number 3. So it says to use a graphing calculator to solve the system. So here, I already did them. The number 3 is infinitely many solutions. There's a C in there, so that's why I knew it was infinitely many solutions. In the calculator, this one came out 2, comma, negative 1, comma, 4. And number 5 says no solution found, so that answer is no solution. All right, for numbers 6 through 8, it says graph the system of linear inequalities. So the first one here, we'll put this one in purple. We start at 1, and we go, our slope shows go up to right 1. And then down to the left one to go backwards. This is a dashed line that's greater than. Alright. For my next one, this one red tells me to start at 2. My slope tells me to go down 1, right 1, since it's negative 1. And then up 1, left 1 to go backwards. And once again, it's a dashed line. And this one is less than, so it's shaded below. So we're shading above the purple, below the red. So right now we're in this region right here. And then for the last one, so start at 4, 1, 2, 3, 4. My slope is positive 3, so up 3, right 1, and down 3, left 1 to go backwards. And this one is a solid line. And the shading is above. So here we're seeing the shaded, triple shaded region is going to be right here. So any point inside this shaded region is a solution, not on this dashed line, but on this solid and on that dashed. All right, for number 7, first thing we should do is to solve this. So here I would just subtract 2x over, and that would be y is greater than or equal to negative 2x minus 2. So we're going to begin at negative 2. My slope is negative 2 over 1, so down to right 1. And then up to left 1. And it is a solid line. And right now the shading is above, so we're looking up here. All right, for the next one, first I'm going to subtract the x. I'm going to divide by negative 1 because I need the y to be isolated. And recall, when you divide by a negative, you flip the inequality sign, so y is now greater than x plus 3. So 1, 2, 3. Go up 1, right 1, because your slope is positive 1. Down 1, left 1 to go backwards. It is a dashed line. And we shade above. So now we're looking at this region right here when we shade above. And then for our last one, here we can subtract the 4x over. So negative y is less than negative 4x. Divide by negative 1. And once again, we flip our sign because we're divided by negative. Y is greater than 4x. So our y-intercept is 0. We go up 1, 2, 3, 4, and right 1. And then we go down 4, left 1 to go backwards. And this is a dashed line. And you shade above, which greater than is here. So it appears this is going to be our triple shaded region right there. All right, on to number 8. First one is already solved, so we start at, let me move this over here a little bit. Start at positive 4. And you go up to right 1. And then down to left 1 to go backwards. And the line is dashed. And the shading is below. So we're looking somewhere currently right down here. Alright, for this next one, we're going to add the 2x. So this time it's at 1, 2, 3, 4, 5. Then we go up to right 1. So you know this line, the slopes are parallel with different y-intercepts. So it appears these graphs won't intersect. This is another dashed line. So right now these current shadings, the green one is going to be shaded above and the purple one is shaded below. So these two actually do not intersect. So regardless of what the third one does, there should be no solution, because if this goes this way, this goes this way, there's a clear gap between them, so they should not intersect at all. So regardless if the third one intersects both of them, not all three intersect in one spot. So I can tell right now that this answer is going to be a no solution. But I'm going to continue to graph the last one though. So I can do this in blue. We start at 6, so 1, 2, 3, 4, 5, 6. And then you'll see the slope is the same again, so another parallel one. But this time this one is solid. Okay, so for the purple one, it says less than, so we shade below. For the green one, we shade above. And for this one, we shade above. So we see that the shadings only intersect here, but not all three intersect in one spot, so there's a no solution. All right, on to the back. All right, so we have this situation right here. And it says you want to work at least 10 hours, but less than 20 hours next week. You earn $8 per hour working at a convenience store and $6 per hour mowing lawns. So that's how I got X is the number of hours worked at the convenience store, and Y is the number of hours worked mowing lawns. You need to earn at least $96 to cover your weekly expenses. Write and graph a system of linear inequalities to model the situation. So for me, this is really not linear programming, because there is no maximum profit or trying to minimize something. So you don't have to worry about that, but once again, in the context of the situation, to pick correct points, we have to, hopefully we can understand that it needs to be in quadrant 1, because that's where all our hours would be positive. Anything into quadrants 2, 3, or 4 produce some negative type of hour, which truly doesn't exist. All right, so my first equation would be, let's see. You earn $8 per hour working at the convenience store and $6 per hour mowing lawns. You need to earn at least $96. So the first one could be 8x plus 6y. You want to earn at least $96. So that could be equation 1. But you're probably going to want to solve that. So let's see. We'll subtract the x over. So 6y is greater than or equal to negative x plus 96. Divide everything by 6. Y is greater than or equal to negative, what is 4/3, 3/4. 4/3 x plus 96 divided by 6 is 16. So there's that equation. For my next one, it says, oh, you want to work at least 10 hours. So hours at the convenience store plus hours as mowing the lawns, at least 10 hours, so greater than or equal to 10. And once here, we just subtract that x over, so y would be greater than or equal to negative x plus 10. Then for the last one, it says but less than 20, so x plus y is less than or equal to 20. So y is less than or equal to negative x plus 20. So those are our three equations. Here, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 16 and 20 won't fit. So I'll go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And 2, 4, 6, 8, 10, 12, 14, 16, 18, and this is 20. So the first one we started 16, which is right here. And down 4, 1, 2, 3, 4, and right 3, 1, 2, 3. Down 4, 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Alright, and this one is a solid line. Okay. For my next one, so starting at 10, then down 1, right 1. Solid line. And then for the last one, starting at 20, and once again we go down 1, right 1. So we're greater than this line, we're greater than the red, but we're less than the purple. So it would be in this region right here. And that would be our solution. Any point within here that makes sense in the context of the situation, that would be the answer. Now, if you just want to get practice in saying, how do we restrict the domain here, range here, so that it is only in quadrant 1. So here you could say that x would have to be greater than or equal to 0. And right here, y would have to be greater than or equal to 0. And that would keep you in the first quadrant. All right, number 10. The Juice Bar Health Club receives a delivery of juice at the beginning of each month. Over a 3-month period, the Health Club received 1,200 gallons of orange juice, 900 gallons of pineapple juice, and 1,000 gallons of grapefruit juice. The table shows the compositions of each juice delivery. How many gallons of juice did the Health Club receive in each delivery? Justify your answer. So we have this table, and hopefully you recall that I said this was a different color. This was X, Y, sorry. These were all X's, these were all Y's, these were all Z's. And pretty much you just add them up. And it equaled a number, but in this case it doesn't tell you the number, but the numbers are here, 1,200, 900, and 1,000. Be careful here because this is 70%, so when you actually write this equation, it would be 0.7x plus 0.5y plus 0.3z. So orange juice was 1,200 gallons. For the next one, 0.2x plus 0.3y plus 0.3z equals, this is pineapple juice, so 900 gallons. And then last, 0.1x plus 0.2y plus 0.4z equals, this is grapefruit, which is 1,000 gallons. Then you would do menu 3.2 to do length solve. You type it in, and your answer should be 300 gallons 300 gallons of orange juice in the, oh sorry, it's just 300 gallons in the first delivery. And then in the second delivery, it was going to be 750 gallons. In second delivery. And in the last delivery, it's going to be 2,050 gallons delivered in the third one. Alright, so we have those there. Okay, on to number 11. A produce store sells 3 different fruit baskets containing strawberries, pears, and oranges. 1 pound of each fruit costs $6.50. 2 pounds of oranges, 1 pound of strawberries, and 2 pounds of pears cost $10.85. 3 pounds of pears, 4 pounds of oranges, and 2 pounds of strawberries cost $18.60. Use a graphing calculator to determine the price per pound of each item. So X is the price per pound of strawberries, Y is the price per pound per pears, and Z is the price per pound of oranges. Alright, so for the first equation, 1 pound of each fruit costs $6.50. So X plus Y plus Z equals $6.50. For my next one, 2 pounds of oranges. Oranges is Z for me, so 2Z. Plus 1 pound of strawberries, which is X. So plus X. Plus 2 pounds of pears, and pears is Y. Equals $10.85. And then for the last equation, 3 pounds of pears. So 3Y. Plus 4 pounds of oranges, so 4Z, and 2 pounds of strawberries, which is 2X, is equal to $18.60. And then when you plug this into the calculator, it's going to come out that strawberries are $2.15 per pound. Pears are going to be $3.10 per pound. And then last, oranges are going to be $1.25 per pound. And then last but not least, we have numbers 12 and 13. So for 12 and 13, it says write the augmented matrix for each system of linear equations, state the dimensions. All right, first thing I'm going to do is I'm going to convert these into standard form. So 4x minus 2y equals 2, that one's fine. And I'm going to leave a space because there's a z there because I can see the other ones have a z. 5x minus 2y plus z equals to 7. 3x plus 4y minus z equals to 3. Okay, so everything actually checked out correctly. Now I'm going to write my augmented matrix, so make sure we use the leading coefficients. So 4, negative 2, there's no number, so 0. So 4, negative 2, 0, line for equal bars, and 2. 5, negative 2, 1, 7. 3, 4, negative 1, and 3. And my dimensions are, there are 3 rows by 1, 2, 3, 4 columns. For 13, this one is definitely not in standard form. So I'm going to keep the 3x there. I'm going to add the 2y over here. There is no z, and it equals 0 since there's a number. Over here, I'm going to first subtract x over. I'm going to subtract the y over. I'm going to keep the negative 3z there. Then I'm going to subtract the 8 to the other side of the equal sign. Alright, I'm going to add the 2x because it says hint all variables to the left, constant to the right, so I'm going to add 2x. That's positive 2x. Negative 4y is where it needs to be, so I'm going to keep it there. Positive z is in the correct spot on this right side. And then this negative 2, I have to add it to the other side to get it over here. And now I have my standard form of equations. So now I can write my augmented matrix. So 3, 2, 0, 0. This is negative 1, negative 16. Negative 3, negative 8. 2, negative 4. 1 and 2, and once again 3 rows by 4 columns, and make sure you do review the linear programming worksheet and you know how to do that.